All right, so let's run through this one. We've got this this purse and wallet problem. Let's see. So what does it say? So it says a purse at a radius of 2 meters, and a wallet of radius 3 meters travel in uniform circular motion. And there's that little drawing there of Phyllis kind of like whirling these two things around. All right. So what you should be picturing here is you've got two things spinning around. All right. So the purse. So let's draw the purse in red. So, all right, so we'll just label this P for purse. All right, and then meanwhile, there's also this wallet spinning around. We'll label that with a W. All right, and the problem tells us that the radius of the purse is 2 meters, and the radius of the wallet is 3 meters. So let's label that. Let's see, radius of the purse, 2 meters. Radius for the wallet, 3 meters. All right. So they're kind of spinning around like this. They're on the same radial line. So basically what that's saying is that, for example, if the purse is here, then the wallet's here. If the purse is here, then the wallet's here. Okay, so they're on the same radial line. Okay. So let's get rid of those little dots so they don't confuse us later on. All right, what else do we know? It says at one instant, the acceleration of the purse is a equals 8I meters per second squared. All right, so what that's telling us is there is an instant at which the acceleration of the purse is 8I meters per second squared. I think I said meters per second before. All right, so remember, I means in the x direction, right? And the fact that it's positive is telling us that that vector is pointing this way. All right, so here's one of the two things that's sort of at the crux of this problem. Remember, your acceleration vector always points towards the center of the circle. All right, so obviously here's the center of our circle. So the question is then, where do I have to put this acceleration vector such that it points at the center? Oh, it's got to be over here, right? Okay, so the point that's being described is right here. So here's where the purse is. All right. Oh, that means that the wallet must be over here, right? Because they're on the same radial line. Okay, so those two dots represent now the location of the purse and the wallet. Okay. So let's see, what else? Now the question wants to know, at this instant, what is the velocity of the wallet? Okay, well, so remember, your velocity vector is always tangent to the circle, and it will always be perpendicular to your acceleration. So my velocity vector is going to point this way. So here's what I'm looking for, is the velocity of the wallet. So it looks like the velocity of the wallet is going to be something j, right? Negative something j, I guess, right? But we need to figure out some information about that velocity, right? So let's do this. Let's go over to the side. So what value ties the acceleration, the radius, what equation ties the acceleration, the radius, and the velocity together? Oh, well, the acceleration of the purse is just the velocity of the purse squared over the radius of the purse, right? Just centripetal acceleration is v squared over r. Okay. Oh, so that means then, let's see, the acceleration of the purse is 8. That's got to equal the velocity of the purse squared over the radius of the purse, which is 2. So multiply by 2, take the square root. Aha, the velocity of the purse must be 4 meters per second. Okay? All right. So if I wanted to, I could do this. Well, no, I guess we're good. All right, so that's the velocity of the purse. All right, and we know the acceleration of the purse points inwards. All right. So now, what is the velocity of the wallet? Well, so going back a little bit, I guess, to honors, remember, velocity is 2 pi rf, right? And the idea is, since both the purse and the wallet are on the same radial line, that means they're both going to have the same frequency. Okay? So your velocity is proportional to your radius. All right? So what that means is, since the wallet's radius is 1.5 times as big as the purse, that means the velocity of the wallet is going to be 1.5 times as big. All right, so this means the velocity of the wallet must be 4 times 1.5, right? Or maybe this is better, 4 times 3 halves, right? So that it's that same ratio, right? Oh, so the velocity of the wallet is 6 meters per second, and it's got to be in the negative j direction. So the velocity of the wallet is negative 6j meters per second, and there's our answer. Okay? So this hits a lot of kind of good points here. Remembering that your velocity is proportional to your radius is really important. Remembering that your acceleration vector always points inward towards the center of the circle is always super important. And remembering that the velocity vector and acceleration vectors are always perpendicular is super important. Okay, so there we go.